Хороший вопрос. Мы по-русски продолжаем или по-английски? Ну, давайте по-английски пока. Okay, so last time we semi-proved the following theorem. Let me call it theorem 1 and state it once again. So for any y1, yl from C infinity mn Rm and any global sections k of them so these are even and these are odd, so C infinity mn Rm so these are odd. Again, okay, so for any such thing, there exists a unique homomorphism phi. So it's a homomorphism in the category of supermanifolds from Rmn to Rlk. Such that the pullback of odd coordinates okay, this I need to fix as well, right? So I need to change that. So let this here and from here x1 x L this will be so theta 1 theta k, so these are super coordinates on RLK. So such that the pullback of xi gives me yi and pullback of theta j gives me psi j. So this is for any I from 1 to L, j from 1 to k. All right. And, well, we said something about existence. So proof. But let me still repeat it. So we need so fix some coordinates on Rmn, right? So x1 prime, x2 prime, blah blah blah, xm prime, and then theta primes. So this has coordinates, super coordinates on Rmn, on Rmn. So let this be. Then, well, these yi's I can express them, well, in terms of these coordinates. So this will be just a function y I tilde of x primes, right? And plus something which is divisible, so to say, by theta, but this lives inside Rmn, right? So therefore, this should be divisible by theta prime, right? And so with some coefficients, so theta prime I should be like that, right? And so here I is greater or equal than 1, the size of I. All right. And so then I define a map phi tilde. So this should be homeomorphism from R Mn, well, from Rm to Rl, right? So I just define it as follows. It just sends coordinates x1 prime, blah, 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 x m prime to y1 tilde of x prime, blah, 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 and how much of them we have, RL tilde of x prime. So this is the map on the corresponding topological spaces. And now we need pullbacks. For pullbacks, I would like to denote this somehow. Let me denote this by y capital I. Right? Then if I have section F, well, local section, where U is inside Rm, sorry, I should pull back, really, so I'm going backwards, so should be this, right? For any such thing, we define, we just put phi star U, the pullback of corresponding to sections on U of F. So it should be in terms of coordinates x prime and theta prime, right? So it's a sum over I, and then I need d I f, and then precompose it with phi tilde of x prime, right? And take y I. And here I should, well, basically any subset of numbers from 1 to L, right? This is right. But sorry, here I know I need what? I need actually not this one because it's not clear how to take derivative of that, right? So I need actually just this, because, well, these are coefficients in front of decomposition into thetas, right? And I substitute something weird inside, like something like x plus maybe something depending on theta. I want to make sense of it. And so formally define it thinking of Taylor expansion. Okay, and then I just claim that it is extends uniquely, so I claim that it extends uniquely to homomorphism, well, phi star u from u to, sorry, phi star u from where to where? From C infinity L k of u to C infinity M n of phi tilde inverse of u. Right, so I just need, well, I just need to see that it respects multiplication, right? So it's really homomorphism of rings. But this is because we have Leibniz rule, right? And we checked like a baby version of this computation on our example last time. And extends uniquely because, well, we know how phi star acts on thetas, right? So these are coefficients. We applied the coefficients and to each theta. And in thetas is just polynomial, so no issue there. Ну, мы хотим вот типа разложение. И там мне нужно как бы написать такое, да, что-то типа единичка на и1 факториал, там и2 факториал, и k факториал. Ну, где и это, значит, и1, и сейчас. Значит, ну тета штрихи. Сейчас, я соображу. А нужно ли это действительно? Значит, вообще говоря, что я делаю? Я же любую производную, ну вот в этом и, они не равны между собой. Да, а ди-то это что значит? Это значит то, что я беру сейчас, но y-ит, да, y-ит я не могу как бы, y-ит в квадрате это 0. Правильно? Это в любом случае. Поэтому, да, потому что я беру как бы производную по x и первому, по x и второму, но все производные первого порядка. Вот, поэтому все-таки, наверное, этой штуки не надо. Ну, единицы, да. Но это неправда, это как бы все равно, вот эти штуки не единицы. Но я как бы беру производную типа d по dx и 1. Но один раз. То есть вот если я это напишу, это неправда будет. Вот если бы я там 2 раза взял, тогда бы единичка на 2 факториал мне надо было бы здесь писать там и так далее. Да, но все эти производные как бы по одному разу берутся. Просто потому, что мы как бы 2 раза не можем взять. У нас там, ну у нас ничего, ну вот это штрих в квадрате это 0. Make sense. Окей, я перешел на русский. В какой-то момент я не заметил даже. Сейчас. Но мы все производные берем степень 1. Все, вот в разложении Тейлора при производной в степени 1 коэффициент 1. Ну, в смысле вот этот комбинаторный. Все. А вот эти индексы — это то, по какой переменной в их штрихе я беру. Right. At which point I don't. Okay, we need to ask the only person. У нас был китаец какой-то, я не знаю, вот он смотрит или чего, или будет он ходить. Он с Калтеха вроде. Вот. Вы не видели его, Сергей? Нет? Сейчас. Давайте попробуем все равно. Но если отвечать на вопросы я буду по-русски, видимо, попробую сам рассказ по-английски. All right. So yes. So it's a homomorphism, and also we have that it should be local, but its locality I put by hands when I defined how phi tilde should work, right? So where was it? Ah, yes. So phi tilde is this. Right, and this, in particular, this can be empty, right? And so the zeroth term is just f of phi, the precomposition of f of phi tilde. Okay, so this is construction, and kind of proves existence if you go through all the checks. So let's work with uniqueness. All right. So again, well, so suppose that we have two morphisms that satisfy this. So suppose that we have two such morphisms. Let's call them phi 2. All right. Again, using locality, we know that phi tilde 1 and phi tilde 2 should be given by this formula. Did we have star already? I don't think so. So locality says that phi 1 tilde and phi 2 tilde should be given by star. Well, this means that phi tilde 1 equals to phi tilde 2. And then let me fix any point x prime. I don't know. Yes. Okay. So first of all, let me fix some local section. So fix some f, which is in C, which I will be pulling back. So from C infinity Lk over some u. All right, and let me also. So my goal is to consider G, which is really difference of two pullbacks with respect to phi 1 and respect to phi 2 of f. So it's phi 1 star of f minus phi 2 star of f. Well, of course, well, I'm pulling back these sections, right? So I'm kind of forgetting about this subindex u. It's clear. So I want to see that this is 0. So I want to see that this is 0. So we want g is 0. In particular, it should be 0 at an arbitrary point of phi tilde inverse of u, right? Well, so fix arbitrary point. Let's call it x, and our coordinate, like we had primes in R, M, N. So this is inside phi 1 inverse of u tilde. Well, which is the same as phi 2 tilde inverse of u. And actually, let me just denote this as phi tilde, not to choose any index. Then let y prime, it just denotes the image of x prime. Okay. Then I have the following claim, which is really can be called Taylor theorem. Well, idea is kind of clear, right? So I'm using, so my, since my pullback is given on coordinates, right? It's uniquely defined on polynomials on such coordinates. But then I use Taylor expansion, and I need some argument, involving Taylor expansion of any function. So therefore, I have this. I would like to use this claim. It says the following: for any s, well, really any positive integer, there exists p. Well, I already fixed my f, right? So I will be applying Taylor theorem to it. So there exists p. So this is a polynomial. So this is polynomial in x, i's, and polynomial in thetas. Okay. This is minus, right? So the anti-commute. Such that f can be written as p plus r, where r is a remainder, and it's locally in my point y prime. It belongs to the maximal ideal. Maximal ideal corresponding to the stock at y prime, and actually to its s power. Okay? Make sense with the statement. So basically, so in Taylor's series, in the usual Taylor theorem says that okay, you have any function you can write down like that, where this is some polynomial, and this is like O small of x to the power s. So that's what's really written here, but in this more general situation of super things. Well, the proof of claim is really easy. You just take your section f. It can be written as f0 of f of x plus some fi of x theta I, right, where I here is the size of I is greater or equal than 1. Then I just apply really Taylor theorem to all the coefficients, right? So I just decompose this guy, p0 plus r0, and then decompose all these coefficients to pi plus ri. And then where r0 here, well, so these are really polynomials that start with the nth power of like local coordinate around so it's a little bit misleading. This y prime is a little bit misleading because my x and theta here, they don't have primes. But anyway, so my y, suppose it has coordinates. So y prime has coordinates y1 prime, y2 prime, I don't know. So how much coordinates? So y prime is a point inside where? Inside RL, right? So I think L coordinates. Then just R0 or I is of the following form. It's just x minus only. So sorry, I'm starting to be a little bit confused. Yes, so x, but y prime is inside. Starting to be a little bit lost in the number of indices, right? So okay, but again, so f. So let's track this down. So f lives where? F lives inside CLKU, right? So it depends on x. Yes. Okay, and x1 blah blah blah. X's and y's are actually coordinates. So x's are coordinates without primes on RL. Yes, so it's all good, I think. So x1 minus y1 prime, x2 minus y2 prime, and so on, and xs minus ys prime times some r tilde, 0 y. Right? So I'm just saying apply around y locally Taylor theorem to all f0 and fi. Okay? So I will get some polynomial plus something which starts with such a factor. Right? It vanishes at y prime. Sorry, should be no. So, да, сейчас, окей, сейчас исправим. Во-первых, okay, so should vanish at y prime of right of and the degree of this vanishing should be s, right? So what should I do? I should take really, I don't know. So it's a polynomial, I should say, right, of x I minus yi prime, right? And this is like a homogeneous polynomial of degree s. Is it better? Yeah, I think so. Okay. So, and then this, of course, gives me the decomposition. So I just take p. My p here is just, let me interchange. P0 plus pi theta I, right? Это, ну как, это как бы, вот я беру, у меня R0 есть, а есть R ita. Вот, как бы вот так. Ну, значит, ну, прямо многочлен мы... Ну, правильно, да. Ну, мне нужно... ну, наверное, надо сумму, как бы. Действительно, тут какая-то должна быть... сумма действительно... ну, ладно, можно как бы вот еще сумму здесь написать. Как бы здесь и здесь и. Ну, в смысле, ну, нет, не это и, конечно, ну, другой, да, К. Ну, вот что-то такое. Ну, ладно, это мы тут упражняемся в разложении теор. Нет, ну, нет, значит, очень, это справедливые жалобы, правильно. Надо, чтобы написано было хотя бы что-то правильно. Я согласен. Значит, ну, вот теперь вроде окей, да? Хорошо. Let me think. So my well, this guy R. Well, the remainder. If I take P is of this form, then the remainder will be I'm thinking, so maybe I don't even have to decompose. Don't even have to decompose. No, it's okay. So I'm kind of overcompensating here a little bit, right? Because that, well, should be inside MS, right? But I have like some number of thetas, right? So I can actually, you know, make this Ri of smaller degree. But I mean, it's still okay, right? Right. So this is, I think I proved the claim. So now I am taking G, and let me consider its stock at x prime. This x prime that we fixed, arbitrary. Okay. So G is this difference between two pullbacks, right? So this is actually So I take my f, apply Taylor theorem to it, right? So I have p and r. So, well, pullback, of course, is linear, so I apply pullback to p and pullback to r. So it is difference of phi star of 1 of p minus phi star of 2 of p, and plus the difference of pullbacks applied to r. So I have phi 1 star r minus phi 2 star r. Now this is 0. Because p is polynomial. Then on polynomials we have everything's good. Okay, so now we have to do this, but this guy, I claim I can write this down just from the definition how pullback induces a map on stocks. This is just phi 1 star applied to r at y prime minus phi 2 star applied to r at y prime. All right, but this guy is inside s power of the maximal ideal, and these are local. So it takes. So these are local morphism, homomorphisms. So therefore, they take s power of m to s power of m. So this guy is inside m's s power of m, but not of y prime, but rather of x prime. So this is because, again, phi 1 star and phi 2 star local. Okay, so now we can actually take S big enough. So remember, we are pulling back from CLK to CMN, right? And K is the number of theta primes. K is the number of thetas, right, which are coordinates on U. So I take K S greater than K. Then what happens? Then my G is of the following form. So this condition that G, the stock of GX prime is inside this, means that G is inside such a vector space. So G1 plus J, G2 plus J, GS plus J, where J here, it's ideal generated by theta. Sorry, I already pulled back, right? So let me. So maybe I need to change. So and again, this is very hard to navigate. So maybe I have to change. So J ideal generated by. So G lives inside Rmn, right? On Rmn we have coordinates theta primes and x primes. So J let be ideal generated by theta I primes. Okay. And so and also we have condition on G's such that G I at x prime is 0. So I'm just expanding this condition that this guy is inside S power of maximal ideal. Okay? it means that it's of such a form. It's well, it's a linear combination of such things, right? But without loss of generality, we can assume that it's actually like a such thing. So here each gi at x prime should be 0, and the rest of the thing is just theta times something, theta prime times something. Now what's important for me is to take s such that j to the power s is 0. So let's see if I put in the correct index here. I think so theta primes, so how much of theta primes I have? I think I have n of them, right? So I think I should put n here. Right? So therefore, what happens with G? So actually, my G is some. So I cannot take like. So this like a bunch of brackets, right? So I cannot take term consisting of only this, the second terms. That's what I mean. So I always have to pick something like gi and times something else. And so I will have gi of x times times something, where fi is inside. That doesn't really even matter. So it's of such form. All right. But we know that gi at x prime is 0, so therefore g at x prime is 0. But x prime was arbitrary, right? So we proved that g is 0. So here the trick is like, okay, technically it might be a little bit, you know, not that involved, but still. But the idea is clear that in Taylor expansion, it's enough to take, you know, in thetas, everything the like after well, you really can use the fact that you know you have anti-commuting thetas, and so everything in theta of degree n just vanishes. So we can make use of that. Yes, so we proved the theorem. And okay, let us observe in general what this theorem implies. It implies that morphisms between supermanifolds, they are defined by how they map coordinates locally. So if you gave me some morphisms and I know what it does with coordinates, then I know everything, basically. So let's formulate it. As a corollary, but this is important, and so you might use it. So corollary. So suppose that I have morphism from x to y. So this is morphism of supermanifolds. Okay, so let also UI be well, here I side I be, well, so to say, superatlas, right? So the cover of X, or sorry, of Y by super coordinate neighborhoods. By okay, super coordinate neighborhoods. And suppose that, well, with super coordinates, let us just name them somehow. I don't know, x1i, x, so it's on, okay, let it be xni, and then theta 1i, theta, maybe here m, and here n. Anyways, so for UI, the corresponding set of coordinates is like that. Then I just want to say that phi is uniquely defined by phi star of UI of, well, xj I and phi star UI of theta k I. So here I is from our index set here. Okay, it's just a really generalization of what we had, like from local to global. To prove this doesn't cost too much, but we just need to point out what we really use. Of course, it's a corollary to theorem 1, but theorem 1 is about well, in theorem 1, I was pulling back well, sections, like global sections on Rn, right? So I can take this and replace Rn and Rl with any open neighborhoods in there. Okay, nothing really changes. So in theorem 1, can replace Rm and Rl by open neighborhoods of open subsets U and V respectively. Then we'll get, oh, the proof is just the same. So then we'll get what can be called theorem 1A. But then, from this theorem 1A, you can replace, you can use it. So then we will get something that we will call theorem 1A. This is one observation, but another observation is that, okay, in theorem 1 we have uniqueness, in theorem 1A also have uniqueness. So this uniqueness with and gluing, uniqueness of gluing of a sheaf gives us that we actually can promote X to any, well, we can promote like this Rm or U to any supermanifold. Right? Because of the uniqueness in theorem 1a, we have uniqueness of pullback to intersections. Right? So therefore, on intersections, our pullbacks coincide, and so we can glue this together by gluing axiom. So how to put this? So uniqueness in theorem 1a plus gluing axiom gives me what I would call theorem 2, right? Which is just theorem 1 with R M N replaced with any supermanifold. Right, so the picture is that, okay, you have, I don't know, you have Y, right, and you have like maybe like two patches on X, right, and so you pull back to here, because of the uniqueness here, your sections, they just, well, the restrictions of the corresponding sections, they just equals, and therefore by gluing condition, I just have a pullback to the whole supermanifold. All right, but then the last step is just to make this to consist not of one chart, but this is again just gluing axiom of, but now like, okay, it should be uniqueness in theorem 2 now, right? So uniqueness in theorem 2 gives me, okay, finally, corollary, or I don't know, theorem 3, which is, I think theorem 3 is just the same as theorem 1 with R M N and R K L or L K, I forgot already, replaced with any super manifolds. Well, now you can add patch here, right? And so you should be able to pull back from, from well, you need to be able to pull back from different patches, right? But again, because they agree on intersection here, by uniqueness they agree on intersection here, and so they all glue together by the gluing axiom. So really, there's not. I just apply the axiom and uniqueness a lot of times, and I promote it to any supermanifold. And basically, corollary is that, well, it's so promoting theorem 1 to any supermanifold is actually more than corollary that I just formulated. In corollary is about uniqueness, but I actually have existence as well, right? So that's it. I think. Let me stop the discussion. So the message that I have here is that if I have pullbacks of coordinates, then I have everything. Okay. So this is it. How much time do I have? Like 8 minutes, right? So let me introduce vector fields then. Maybe I will not have time to prove anything about them, but let me introduce vector fields on supermanifold. And actually we'll just see what's the basis of local basis for vector fields on supermanifolds. All right, so let me fix a supermanifold. So this is supermanifold. And so this is the definition. Then a vector field V on X or X is the following thing. So it's a collection. So it's a collection. Maybe you can say it fancier, but no. Let me know if you think of something. So collection. That. Of super derivations. So VU, right? So for each U open subset inside X, I can consider sections of X, OX, and so I would like to consider super derivations from OX of U to OX of U. So for each U, so it's a collection of super derivations VU labeled by U, such that well, so here, let me still put it on board. So for each U in X open, such that they commute with restrictions. So VU restriction from V to U. So here I suppose that U is inside V of F is the same as first I restrict. So first I restrict, then I apply a vector field, or I can apply a vector field but on V and then restrict. This is for any F in OX of V and any UV such that U is inside V. Okay, so this is the definition. We can see which derivations we have out there, but really there's not too much. Well, locally. So locally means that I would like to consider vector fields. So vector fields of R M N. All right. So, okay, so I can, consider some open subspace of Rm again. Parentheses here. Well, there are usual vector fields, just even ones, right? Which work as follows. So I take some section, so which can be written like this. And well, I have x and theta are coordinates on my Rmn. So then this is just d of dx applied to each coefficient, so like that. So just f d over dxi applied to fi theta I. Well, of course, this super derivation. This is really just a derivation, but super derivation because it's even. So should not should the yeah. So the sign should not appear. So okay. So here the summation over I. But then also we have derivation with respect to theta. So how to define it? So, well, notation will be d over d theta, j, say. Well, it's a left derivation, right? Well, I'm sure you saw this somewhere. So you just need, so it acts on the polynomial on theta as follows. You just, if this monomial has theta j, you move it to the left and erase. If it doesn't, then the result of the application is 0. Okay, so let me fix this somehow. So for any well, let me just fix f from C infinity of R M. And theta I such that, well, there's no theta I, theta j inside, so theta j, theta I is not 0. Let me write it like this. Then I just put the d over d theta I of f theta I is just 0 for any f. Maybe, I don't know. I kind of tried to put the requirement that it doesn't see just usual even functions, but maybe it's better to put it. Okay, anyways. So this is just 0, and then d over theta j here. D over d theta j of f theta j theta I is just f theta I. Okay, so this is in formulas what's going on. All right, so I'm out of time, unfortunately. So let me stop here. But we will see that for RMN, this is the basis for derivations on the algebra of sections in RMN. Oh, global or local, doesn't really matter. You can restrict them. All right. So. Да, из-за вот этого, да?
Нет, вот обычно я не понял, можно слить просто как дифференцировать на алгебре всех функций, просто там просто из-за вот свойства дифференцирования следует, что
Решение. Да, а здесь я говорю, что хорошо, давайте просто на глобальных, ну, можно, и тогда вы говорите, что это может быть выполняться автоматически. Да, я понимаю, а здесь сейчас я подумаю.
Ну, это, мне кажется, вопрос, в чем примерно правильно здесь только существует, например, глобальное нечетное сечение.
Но здесь как-то мы, здесь надо думать, не, мне кажется, что, вот не могу сказать сразу, что это правда. Надо подумать. Но в книжке это как бы условие, да. То есть там прям так и написано, что это, значит, вот супер производные вот такие, что они коммутируются с ограничением. Типа bump function. Ну, можно просто... а что вы от нее просто хотите? Надо подумать. То есть, ну, можно такую как бы на все коэффициенты навесить функцию. Но не знаю, будет ли она работать. То есть надо как бы провести это доказательство, мне кажется. Попробовать, куда мы упремся. Да, не очень понятно сейчас. Нет глобальных нечетных. Ну, в принципе, да. Ну, а чего может сломаться? Ну, в смысле, вы хотите, чтобы вдруг, а там в другой карте, которая на нее заходит, да, чего? Мы делаем какую-то переклейку, там, ну, это как-то меняется. Но, тем не менее, если она там уже ушла в ноль, то она как бы, вот вы разложили, она в какой-то точке все коэффициенты нулевые. Вот за шапочку ушли. В принципе, переклейка вам тоже должна выдать ноль, если она нормально. Ну да. Без глобальных? Ну, вообще без сечений.